Okay, so today what we're going to do is a one-pager EOG review. A lot of times teachers will tell you to study for the EOG, or you'll want to study for the EOG, but you might wonder, well, what am I supposed to study? We've done a lot of work, you had a lot of notes, you had a lot of worksheets, a lot of quizzes and tests, and sometimes that can kind of be overwhelming to know, okay, what do I need to know in order to do well on the EOG? And, can we kind of condense it down so that I'm not studying all day and so that I'm not studying tons and tons of paper, especially if maybe you lost some things from quarter one or quarter two. So what we're going to do today is create a one-pager EOG review. This is just one page, front and back, of all the important things that you need to know in order to do well on the EOG. If you study and commit these things to memory, then you should have an easy time passing the EOG. So what I'm going to do is go through, and you'll see on every slide, every box is already filled out. I'll talk a little bit about the box, and then you can pause it if you continue to need more time in order to write down everything that I've written on my paper. Okay, let's get started. So the first box is about scientific notation. Our exponents tell us how many times to move the decimal. So in my first example, I have 1.43 times 10 to the fourth power. Since the fourth power, that exponent is positive, then that means that I'm moving my decimal place 4 places. Remember, the 4 doesn't necessarily relate to how many zeros, it relates to how many decimal places we move. So if my decimal is at behind the 1, and I move it 4 places, then I still have 2 empty spots, and that's where I put my zeros. So my answer is 14,300. Now, for our next example, it's 1.43 times 10 to the negative fourth power. Negative lets me know that I am moving my decimal place to the left. So again, I just count how many places I'm moving. If it's after the 1, I'm moving over 4 times. The 1 takes up a placeholder, but then I have 3 more empty places, so I need to fill those with zeros. So in scientific notation, numbers with the positive exponent are big numbers, and our numbers with a negative exponent are our smaller numbers. You might have maybe 1 or 2 problems on scientific notation. It's usually not a lot, but 1 or 2 problems can be the difference between making a 2 or making a 3, or a 3 or a 4. Our next area is volume. Now, I put the area formula for a circle at the top. That's something you've learned in 7th grade, pi r squared. So that's something you're going to have to commit to memory. Now, instead of just sitting here and writing down just the formulas, I decided to write beside the formula exactly what you do. Because if you understand the concept of what you do and why you do it for volume, then you should always get these problems right. So we know for a cylinder, it's always the area of our base times our height. So you need to find the area of what the base is. In a cylinder, the base is a circle. So we're going to find the area of a circle, which is why we have the formula up there, pi r squared, and then we would multiply that by the height. For a cone, you do the exact same thing. But remember when we were learning about this, we talked about how if we were to fill a cone with sand or water and pour it into a cylinder, we would have to fill 3 cones in order to be able to fill 1 cylinder. So that's why we use the same formula, but we're going to divide our answer by 3. Because the volume of a cone is 1/3 the volume of a cylinder. So if you know how to find the volume of a cylinder, just divide that by 3 to find the volume of a cone. Now the sphere is where it gets a little bit complicated. Remember, we are looking at a 3-dimensional figure, so there isn't a height on the sphere, which is why we are multiplying the radius by itself 3 times. So our formula is 4/3 times pi. We know that's 3.14. The problem will usually tell you to use 3.14 instead of the pi button. So don't worry about figuring out which one to use. The problem will always tell you whether to use the pi button or use 3.14. And typically they say to use 3.14 instead of pressing the pi key. So we have 4/3 times pi times radius cubed, because we're talking about a three-dimensional object. So instead of r squared, we have r to the third to represent those three dimensions in our sphere for volume. And those are the only three you need to know for volume for 8th grade. Pythagorean theorem. I promise you, you will see at least 2 or 3 problems on Pythagorean theorem. Usually there'll be word problems about a ladder leaning up against the building. If, the building's height is this and it's this far from the base, what's the height of the ladder? Anytime you see things like that or problems like that, draw a picture. When you draw a picture and you see your picture looks like a right triangle, always think Pythagorean theorem. So we know Pythagorean theorem is a squared plus b squared equals c squared. And that's just something you have to commit to memory. We know our legs are a and b. Those are interchangeable. And that our hypotenuse is always our longest side. And that is always c. It is not interchangeable. When we're finding them, we're just squaring what we're given. We're adding it together. And then we're taking the square root to find the hypotenuse. If we were trying to find a leg, we would just subtract our squared numbers and then take the square root. So we follow the same process. It's just kind of working backwards if you're looking for a leg as opposed to looking for the hypotenuse. But the main thing to remember is a squared plus b squared equals c squared. Calculator info. Some important things to remember on the test, because a lot of times you might be afraid to ask, you might be nervous, or things might be happening. 2 things you always need to know how to do: reset your calculator and to get out of a screen. So your calculator should come to you already reset. If it's not, just press second plus 712 and you'll see RAM cleared, and that means your calculator has gone back to its basic functions. So let's say you were trying to graph systems of equations and you kept messing up, or you couldn't see the whole graph, or some things were going on. Resetting your calculator will help you out and put it right back to the way you want it to be. Now, if you get stuck in a screen that you don't want to be in and you're like, I don't know how to get out of this screen, I want to go back to just the main calculator screen, you can press second mode, which will take you to quit, and that'll always put you back to the main calculator screen. So these are 2 things that are important to remember for the EOG, so that way when you do calculator active, you're not sitting there stuck because your calculator's messing up and you don't know what to do. So when we're trying to find slope, this is something that we need to commit to memory. y2 minus y1 over x2 minus x1. And so here I have points 5, 10, and 12, 15. Remember, it doesn't matter which one is our first ones and which one is our second one. It makes sense to just make the first one 1 and make the second one 2, just for ease of use. So when you label them, I always encourage everyone when they're doing these problems to go ahead and write down the formula so that you can see it and you remember it. Then I like to go ahead and label my x1, y1, my x2, my y2, instead of trying to do it in your mind, because that's how you make simple mistakes. Once you've labeled them, then you just know, oh, I just look at my y2. My y2 is 15, so it's 15 minus 10. And then I have 12 minus 5. So labeling it makes it really easy to make sure you set up the problem right, because everybody can subtract. But where we go wrong is making sure that our y stay with our y, our x with our x, and that our 2 comes before our 1. So commit that formula to memory, because you'll probably see a couple of problems on the EOG for slope 2. Okay, Unit 1, we talked about real number systems, rational and irrational numbers. I've listed here all of our natural numbers. Remember, natural numbers are our counting numbers. So these are the numbers when you were in kindergarten and the teacher said, okay, boys and girls, everybody count to 10. And you say 1, 2, 3, 4, and so on. Those are our natural numbers or counting numbers. So think back to the first numbers you learn. We always learn 1 through 10, right? And it goes on and on infinitely, but we always learn those whole numbers, right?